What is going on, guys? Welcome back. In this video today, we're going to learn how to actually deploy machine learning models properly on a server. So let us get right into it. Alright, so we're going to learn how to properly deploy a machine learning model on an actual server in this video today. Now, the only prerequisite for this video is that you know how to train any machine learning model, be it with scikit-learn, be it with TensorFlow, PyTorch, it doesn't really matter. You just need to know how to train a model, how to save a model, and how to load a model. I'm not going to cover this in this video today. Now, of course, we're going to load the model, but I'm not going to explain how to train a model and how to export it. I have a bunch of videos showing how to do that. This video today is focused on the deployment. Now, I am going to use a PyTorch model. However, you can do the same thing with scikit-learn and TensorFlow. You just need to adjust the code so that it works with your respective package and your respective model. The focus today is on packaging it as a web application and deploying it onto a server. So in my case here, I have a PyTorch model trainednet.pth. And this contains the model parameters for a simple convolutional network, which classifies the Cypher-10 datasets, so 10 classes of images. And this is what we're going to deploy to a server today. Again, use any model you like. You can use a k-nearest neighbors handwritten digits classifier if you want to. It doesn't matter. Just know how to load the model and how to then use it. Everything else is just a web application around it and deploying it. Alright, so I'm going to start here by creating a Python file, which I'm going to call network.py, and then I'm going to use this file in a web application, in a Flask web application, to package it as an application, so as an API, with also a basic HTML frontend, and then I'm going to deploy it on an actual server on the internet. Alright, so I'm going to start here, first of all, by installing the packages that I need, so pip3 install, I'm going to need Torch, I'm going to need Torch Vision, I'm gonna need Flask, and I think Pillow as well for the image processing. Now, either I already have a video on this channel, or I will upload it soon, where I'm going to show you how to actually train this model, how it works. I'm gonna explain it in more detail. Today I'm just gonna load it and use it, but I'm gonna make a video soon, or as I said, maybe it's already on the channel, where I show you how to implement such a convolutional neural network to classify images in PyTorch. This is the one that I'm using here. So right now it's installing PyTorch, and once this is done, or actually I can already start with the coding. Here we're going to import Torch. We're going to import Torch dot, actually I'm missing an R here, torch.nn as an N. I'm going to import torch.nn.functional as F, and then import torchvision.transforms as transforms. Now, again, I'm not going to focus here on any explanation regarding the model because, as I said, there's a separate video for that. What I want to do here is show that in general, all you need to do for a PyTorch model is you need to define the same model architecture that you used for training. You just have to create the class and then you can load the model parameters. In the case of a scikit-learn model, you can just pickle or serialize the whole model and load it. In the case of TensorFlow, I think you should also be able to just save the model and load it. So depending on what package you use, oftentimes you just have to literally load model. And in this case here, I need to define the architecture first. So I'm going to say class neural net, and I'm going to speed run this part here because it's really not important. Actually, I'm going to even copy paste it because I really don't want to focus at all on the logic here. I just want to copy paste the class. So this is exactly the class that I used for training. So this is exactly what I used for training the model in my script where I have the whole logic with the epochs and so on. And I need to define the structure so that I can load the model weights, because the model weights are for this structure. I cannot just load the model weights without a structure. So this is what I do. I define the class exactly the way I defined it for training. Again, I'm repeating, if you have TensorFlow, usually it's something like save model, load model. If it's scikit-learn, it's pickle, dump, and pickle load. So you just have to know how to export and import your model. And then what we do is we build a function around it. We say def classify image. And if in your case it's a different task, like a regression task, you just adjust the function accordingly. And what we do here is we pass a parameter image, and we're going to do the following now. We're going to say that the net is going to be a neural network. We're going to say net.loadStateDict, so we're going to load the model parameters, the weights and biases. So it's going to be torch load trainednet.pth. And then now basically I have my trained network. So I have another script where I built this and trained this, I export it, and now I have the trained model here ready to use. All I need to do now is I need to do an inference, so I need to make a prediction. How I do that is I define first of all the list of classes. In the case of the Cypher 10 dataset, it's plane, car, bird, cat. If you're in any way confused what I'm doing here, I recommend watching the other video first if you're really interested in the model itself. So cat, deer, dog, frog, horse, ship, and truck. These are the classes. And then we're going to just take the image and make a prediction. So we're going to say the new transform here, or actually I can call it transform, is equal to transforms.compose. And I'm going to have a pipeline here of transformations. The first one is no matter what image I feed into this, it's going to be resized to the size 3232 because that's my model size. I'm going to say transforms.toTensor. So I'm going to normalize this and turn it into a PyTorch tensor. And then I'm going to actually call the normalize function. I'm going to pass here 0.5. 0.5, 0.5 is a mean for each channel, and 0.5, 0.5, 0.5 as a standard deviation, just because this is how I also trained my model. And then I'm going to do image equals new, or actually I call this transform image. So we feed the image through the pipeline, we get a new image, we add an additional dimension, so we say image is equal to image.unsqueeze. We do that to have the batch, so we basically have a layer around it. Then we put our network in evaluation mode, and we say with torch.nograd to disable any gradient calculations here. We're going to say that the output is going to be equal to predicting what the image is with the net. Then I get something that I don't need, and the prediction predicted is equal to torch.max, and I want to maximize, I want to get the maximum value of the output. I want to get just one value here, and then I return from class names, so from classes, I return the predicted item. So again, this here depends completely on you. Actually, this whole file here depends on your model. Again, if you're using TensorFlow, you import from TensorFlow, Keras, models, I guess. I mean, actually, maybe I can see from TensorFlow, Keras, what is it? Probably models. Oh, I don't know. You just have to know how it's done for TensorFlow. I think it's load model from something like that. It's a function load model. It's a function save model, I think. And in the case of scikit-learn, you just use pickle to dump the model. And then you use it here. So in scikit-learn, you usually have something like model.predict, and then you pass something to it. It doesn't matter. You just need whatever code you need to make the prediction. So here, you put the part where your model does the inference. The actual deployment part starts now, which is building an application around it. Now, you can do that with Fast API or Django as well. I'm going to use Flask here. And for this, I'm going to create an app.py file. I'm going to say import, or actually from Flask, import Flask, a render template, request. What else do we need? Actually, I think that's it. And then also from network, import classify image. So this is from my file here, the method or the function. Also, we're going to need pillow, or actually from pill import image. And besides that, I think I also need the core Python package IO for the byte handling. And then we can create our simple Flask application. So it's going to be Flask underscore underscore name underscore underscore. The template folder is going to be equal to templates, which I think is also the default. And then we're going to define our index route. The index route will just give us an HTML file. So we're going to say here def index return render template, and I want to render the index HTML file, which I don't have yet. And then the interesting part will be packaging our functionality. So again, depending on what kind of model you have, if you have a handwritten digit recognition, maybe you also want to do an image upload. If you have something like you pass in parameters and you want to classify some tumor or some flower or something like that. Based on parameters, you might want to have text boxes and you might want to get them from the form fields. In my case here, I want to upload an image. So I'm going to create a route, which is going to be called /upload. It's only going to accept post requests, so methods equals post. And then I want to have an upload function here, and this function will say if image not in request.files. If that is not present, I will say no file passed. Otherwise, I'm going to say file is equal to request files and image. So now I have the file, and all I need to do now is I need to say if there is a file, image is going to be equal to image open IO bytes IO file dot read. So that is basically it. So this is the image, and now of course what I need to do in order to get a response is I need to return an f string which says classification is going to be equal to calling classify image on the image object. So that's basically it. This is our functionality, and I also want to have a section here where I run this. So if name is equal to main app.run. And in this case now it doesn't really matter where I run it because, or what I pass here, because I can just run it on localhost and use it directly. When I deploy it, I need to make sure I use the proper IP address here. So for now, I'm just going to say debug equals true. And one more thing that I need is I need to have a directory, templates, and I want to create a file here, the index.html file. And here now I'm just going to say image upload. And the important thing is I want to have a form where I can actually upload an image. So the action is going to be equal to /upload. The method is obviously going to be post. Now it's important to pass an encoding type, which in this case is going to be multi-part form data. And here now I want to have an input of type file. Let me maybe zoom in a little bit. Input type file. The name is image. And it accepts everything that is an image. It doesn't matter what kind of image exactly. It's required. And then I also want to have a button with type submit. And I want to upload image as text here. All right, so let's run this and see if it works locally. So this is just packaging our model as an application. So right now, actually, I need to have, let me just open this on a second screen so I don't show too many of my files. Or actually, where was this now? Can I go back? I don't think so. Oh, there you go. Okay, so actually here I have already a directory where I only have these two examples. I have an example of a plane and I have an example of a dog. So I can just, actually, I need to open my browser here again. There you go, browse. Example 1, upload image, classification plane. Example 2, upload image, classification dog. So this works already on my system locally. So how do I get this now onto an actual server? Now, obviously, you need to have a server first. So depending on whether you have your own computer here, whether you have some online instance that you're renting, you just need to connect to a server and you need to somehow be able to transfer files. If you don't know how to do that, it's done easily with SCP or with FTP. It doesn't matter. Just find a way to get your stuff onto the server. But before you do that, you need to first make sure that everything is compatible. So the best thing that you can do is you can start working with virtual environments. So if I go to my directory right now here, I have all these files, but I also have all my Python packages that I'm using. I have my full Python installation here. So what I want to do is I want to say python 3-m-venv.venv to create a virtual environment. So I have no packages basically. I can then activate it because I can say ll, I can see there is this venv directory, and now I can say on Linux at least source and then .venv bin activate, and now I have this environment set up. And if I now try to start this application, app.py, you're going to see it doesn't know the package pill, it doesn't also know the package torch and so on. So what I need to do is I need to install these packages here for this virtual environment. So I need to say pip install torch vision, and pillow, and what was the other one? Flask, of course. So I'm not going to do this now because I have to wait, but basically you do that for the virtual environment, and then what you can do is you can export whatever is in your virtual environment, or actually let me do that. Let me do that so that I can show you the process. So again, Flask, torch vision, and pillow. I'm going to install this. This is now going to install it in this environment. So this environment literally only has these packages and all the dependencies installed. And then you have this clean setup that you can just export to a requirements file. And once you export this to a requirements file, you can easily just upload the requirements file and install everything on the server exactly with the same version. So right now you can see everything is being installed. And once all the packages are installed, we can run the pip freeze command or pip3 freeze command to see all the dependencies and their versions. So this is what is installed in our virtual environment, and we can export that by using the closing angle bracket. So pip freeze, export this to a requirements.txt file. And when I print the content of this file, you can see it's the same as running the command. So this is the file that I want to have on my server to install the exact same packages with the exact same versions on the server side. So what I'm going to do now is I'm going to run an SCP command. So I have a server which I rented online, and I can connect via SSH to that server. You should set up something similar for yourself. So you want to have a server, you want to have SSH access, and then you can use SCP, which I also made a video about recently if you want to go and watch that. It's basically just a command that allows you to upload and download files via SSH. This file now, or this command now allows me to upload my requirements.txt file to the server by saying scp requirements.txt and then root at IP address. And in my case, I have a private public key set up. Actually, I need to also specify a path. So :root / requirements.txt, because now actually I just created a file with the name root at IP address. Let's delete that. So I uploaded the file now. I can connect to the server. So again, root at IP address. This should now connect me, hopefully. So basically what you want to have is you want to have a server that you can somehow access via SSH. So you can log into that server, be it with a password, be it with a public private key, which I also have a video about on this channel. So how to set up an SSH authentication on a server. You need to somehow authenticate yourself, log into a server, and this allows you to also use SCP to upload files. I'm not sure why my connection is lagging right now. So maybe this is just some server issue right now, but you should be able to connect to your server. There you go, I'm inside of it. And here now I have my requirements.txt file. Now it seems like my server is a little bit laggy, which is unfortunate, but it shouldn't be that much of a problem. Here now what I'm going to do is I'm going to say python3-mvenv, and I'm going to create a virtual environment as well. And I'm going to use the requirements.txt file to do the installation. Now I'm going to skip this process because it seems like my server is very slow at the moment, but you create your virtual environment, you do the same thing of source and then venv bin activate, and then you just do pip3 install -r requirements.txt, and this is going to install all the dependencies on the server. Now I'm going to skip that process because it's going to take some time, and I'm going to get back to you once it's done. Alright, so the installation is now done. The next thing we need to do is we need to upload the rest of the files to the server. For this, I'm going to open up a new terminal. I'm going to navigate to my current directory again. And here now I'm going to create actually a new directory. Let's call it deploy app or something, just so I can upload everything as a directory. So I'm going to just take all of this. I'm going to move this. So there you go. Refactor, and now I'm gonna say scp-r deploy app root at IP address, and then root like this, and this should now upload everything to the server. And now I should have this deploy app here, so I should be able to go into the deploy app, and I should be able to run python3 app.py. However, I think that I will need to change, or I know I have to change certain things, because now this is running on localhost and I want this to be running publicly. So I need to actually go into my app.py file, and I need to go to the bottom section where I say app.run. And I need to say that, first of all, I don't want to run in debug mode anymore. I want to say that the host is equal to 0000. That is the IP address that I want to be running this on. So Python 3 app.py, run this, and hopefully this will not take up too much RAM because I'm running this on a pretty weak server right now. But once I have this, there you go, it's running. I should be able to just type in my IP address here in the browser. And actually not, because this should be running on port 5000. So we're going to say 5000 now. And there you go. This is my application. Now let me again just move this to the second screen so I can go to the directory where I have all the files. There you go. So now here I choose example1 JPEG. I upload the image, and hopefully the server doesn't crash. There you go. Plain, classification plain, example 2, upload image, and it's a bit slow as you can see, but classification should be doc. There you go. So this is now running on an actual server. This is running as a Flask application on the server. Of course, when I end this, so when I terminate this, this is no longer going to work, so it's going to be offline when I run this, but you can see that this ran as an actual application. So this is how you can take a machine learning model, turn it into an application, or at least an API, and run it publicly on a server. Now, if you want to know how to do that with a Docker container, I also have a video on this channel where I show you how to do that. I think it's the last part of my Flask tutorial series, so you can take a look at that. But this is how you generally do that. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.